Hey guys, tonight we're diving into the strangest facts about the universe, a place so wild it makes your weirdest dreams look like a grocery list. Picture yourself floating in a vast, glittering void, stars winking like they're in on some cosmic joke. The universe is a mind-bending puzzle, galaxies spinning, black holes slurping time, and planets that rain glass. You're about to drift through 2 hours of the oddest truths space has to offer, and spoiler alert, you probably won't survive the sheer scale of it all. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment with your location and local time. I'm curious where you're chilling tonight. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start your cosmic trek with the universe's quirkiest oddities, the stuff that makes astronomers spill their coffee. Imagine a rogue planet, untethered, drifting through the void like a cosmic drifter. These worlds don't orbit stars. They just wander, cold and lonely, maybe even outnumbering the stars themselves. Scientists estimate billions of these free floaters exist in our galaxy alone, some possibly hosting subsurface oceans warmed by their own guts. One mainstream fact: the first rogue planet, PSO J318.5-22, was spotted in 2013, glowing faintly in infrared, refusing to play by the rules of orbits. Now here's the quirky bit: some rogue planets might carry life, microbes hitching a ride in those hidden oceans, surviving without a sun's kiss. Historians still argue whether these worlds could redefine what we call habitable. You drift deeper and the universe gets weirder. Galaxies aren't just pretty spirals, they're cannibals. Our own Milky Way is snacking on smaller galaxies like the Large Magellanic Cloud, slowly tearing it apart with gravitational claws. You can almost hear the cosmic crunch as stars get ripped from their homes, flung into new orbits. This isn't rare. Galactic cannibalism shapes the universe. The Andromeda Galaxy, our closest big neighbor, is headed our way, set to collide in about 4.5 billion years. Don't worry, you won't need to RSVP. The stars are so spread out, it's more like a slow dance than a car crash. But the idea of galaxies eating each other? That's the universe flexing its savage side. Now picture a star that's not a star. Brown dwarfs, the universe's awkward teens, are too big to be planets but too small to ignite as proper stars. They just sit there, glowing faintly like a cosmic ember that never caught fire. Some are so cool you could theoretically touch them without vaporizing. Well, if you could survive the trip. Here's a light joke for you. Why did the brown dwarf fail at stand-up? Because it couldn't get the room to light up. These misfits challenge what we think a star should be, blurring lines in astronomy textbooks. You're floating past nebulae now, glowing clouds of gas that birth stars. But some are cosmic graveyards too, where stars explode and scatter their guts. The Crab Nebula, formed in 1054 when a supernova lit up Earth's sky, is still expanding, a ghostly reminder of a star's violent end. Monks in China and stargazers in the Middle East recorded it, bright enough to see in daylight. That's your historical anchor. Humans have always looked up, awestruck. But the quirky twist? Some nebulae might hide zombie stars, white dwarfs that cheat death, reigniting in faint bursts. Astronomers still debate whether these undead stars are common or cosmic flukes. You pause, imagining the universe as a vast, chaotic soup. It's not just stars and planets, it's littered with oddballs. Take interstellar objects like Oumuamua, that cigar-shaped rock that zipped through our solar system in 2017. Was it an asteroid, a comet, or, dare we say, an alien probe? Scientists lean toward natural, but the debate's still spicy. Another joke: why did Oumuamua ghost us? It didn't want to deal with our baggage. This wanderer reminds you the universe loves throwing curveballs, objects that don't fit neat categories. As you drift, you notice the universe isn't static. It's alive, messy, and full of surprises. From rogue planets to galaxy munchies, it's a place where rules bend. You're just getting started, and already the cosmos feels like a fever dream. Ready to dive deeper? The stars are waiting. You're still floating in the cosmic soup, the universe's weirdness washing over you like a cool breeze. The stars above aren't just twinkling dots, they're rebels, misfits, and outright weirdos that laugh at the rules of physics. You're about to meet the strangest of them, the ones that pulse, explode, or vanish like they're playing hide-and-seek with the galaxy. Buckle up, because these stellar oddballs make the night sky feel like a circus. Imagine a star that throbs like a cosmic heartbeat. These are Cepheid variables, stars that swell and shrink, brightening and dimming on a schedule so precise you could set your watch to them, if your watch worked in space. A mainstream fact: Cepheids are astronomy's yardsticks. used since the early 1900s by Henrietta Leavitt to measure cosmic distances. Her work helped us realize the universe is bigger than our galaxy. But here's the quirky twist. Some Cepheids act drunk, their pulses stuttering in ways that baffle scientists. Are they binary stars messing with each other, or is something weirder at play? Historians still argue whether these non-classical Cepheids are flukes or a new class entirely. Now, picture a star that just disappears. You're staring at a patch of sky and poof, a star's gone, no explosion, no goodbye note. These vanishing stars have been spotted in old telescope data, like one in the Kinman dwarf galaxy that winked out around 2015. Astronomers expected a supernova, but it just ghosted us. Maybe it collapsed into a black hole without fanfare, or it's hiding behind cosmic dust. Either way, it's like the star decided fame wasn't for it. Joke time. Why did the star quit showbiz? It wanted a low-key life in the void. You drift toward another oddity. Magnetars, stars so magnetic they could wipe your credit card from a light year away. These neutron stars, born from supernova explosions, spin fast and pack magnetic fields 1 trillion times stronger than Earth's. One mainstream historical tidbit. The magnetar Esjar 1806-20 unleashed a gamma-ray flare in 2004 so intense it briefly messed with Earth's ionosphere, despite being 50,000 light-years away. That's raw power. The quirky bit? Magnetars sometimes glitch, suddenly spinning faster for no clear reason, like a cosmic figure skater pulling in their arms. Scientists debate whether these glitches come from starquakes or something deeper, like a crust cracking under magnetic stress. Then there's the star that refuses to die. Meet the zombie star in the constellation of Pegasus, officially IPTF 14 Achelis. It exploded as a supernova in 1954, then again in 2014, and kept on shining, defying every model of how stars should end. Imagine a firework that keeps bursting over and over, mocking the laws of physics. This undead star might be chugging along on leftover fuel or something totally unknown. Another light jab. Why is this star so stubborn? It's got a cosmic bucket list it hasn't checked off yet. You're now gliding past Eta Carinae, a star so massive it's on the verge of self-destruction. In the 1840s, it threw a tantrum, briefly becoming one of the brightest stars in the sky, visible from Earth despite being 7,500 light-years away. This historical outburst, called the Great Eruption, left behind a glowing cloud called the Homunculus Nebula. Eta Carinae still ticking, ready to go supernova any millennium now. The quirky kicker? It might already have exploded and we're just waiting for the light to reach us. Astronomers still argue whether it'll form a black hole or just scatter its glitter across the cosmos. As you float, you realize stars aren't just glowing orbs, they're drama queens with personalities. Some pulse like cosmic lighthouses, others vanish like they owe the universe money, and a few just refuse to stay dead. It's a stellar soap opera and you're hooked. The universe is alive with these weirdos, each one a reminder that space doesn't care about your expectations. You're ready to dive deeper, maybe towards something even stranger, like the black holes waiting in the next corner of the void. You're drifting deeper into the cosmic wilds, the universe's glow fading as you approach its darkest enigmas, black holes. These aren't just the vacuum cleaners of space, they're rule benders, time warpers, and downright show-offs with tricks that make your head spin. Picture yourself hovering just outside their grasp, where light itself gives up and reality gets a rewrite. You're about to uncover the strangest things black holes do, from spitting cosmic jets to twisting time like a pretzel. Start with the basics. A black hole is born when a massive star collapses, squeezing its mass into a point so dense it warps spacetime. A mainstream fact: John Michel, an 18th-century astronomer, first theorized dark stars in 1783, predicting objects so heavy even light couldn't escape. Fast forward to today and we've got proof. The Event Horizon Telescope snapped the first black hole image in 2019, a glowing ring around the beast in galaxy M87. But here's the quirky bit. Some black holes shoot out jets of plasma, moving near light speed, stretching thousands of light-years. Imagine a cosmic fire hose blasting from an object that's supposed to swallow everything. Scientists still argue whether these jets come from the black hole's spin or the chaos of its accretion disk. Now you're circling a spinning black hole and time starts to misbehave. Near the event horizon, the point of no return, time slows for you compared to someone far away. Spend an hour there and years might pass back on Earth. This isn't sci-fi, it's general relativity, tested by experiments like the 1971 Haffel-Keating study, where atomic clocks on planes lagged slightly after flying. But the weird twist? Some black holes might let you skirt their edges and return, aged barely a day while centuries zip by elsewhere. It's like the universe's ultimate jet lag. Joke time. Why don't black holes make great vacation spots? The time dilation's a killer on your social calendar. Then there's the black hole that sings. In the Perseus cluster, 250 million light-years away, a supermassive black hole vibrates the surrounding gas, creating pressure waves that translate to a sound, a note 57 octaves below middle C, too deep for human ears. This cosmic hum, detected in 2003, is the universe's lowest bassline. Quirky fact: if you could hear it, it'd feel like the universe is serenading you with a lullaby from the void. Astronomers debate whether these waves help regulate star formation or just add to the cosmic ambience. You drift toward rogue black holes, loners wandering the galaxy without a stellar entourage. Unlike their flashy cousins at galaxy centers, these drifters, possibly millions in our Milky Way, sneak through space, detectable only when they bend light from distant stars via gravitational lensing. Historical nod: Einstein predicted this lensing in 1915, and it's been confirmed countless times, like with the 1919 solar eclipse observations. The quirky kicker? Some theorize these rogues could be primordial, born in the Big Bang's chaos, tiny as atoms but heavy as mountains. Are they dark matter's missing link? The debate rages on. One last oddity: black holes might evaporate. Stephen Hawking's 1974 theory suggests they leak tiny bits of energy, Hawking radiation, slowly shrinking over eons. A black hole the mass of the sun could take 10 to the power of 67 years to vanish, but mini ones might pop like cosmic fireworks. Joke number 2. Why is a black hole's diet so strict? It's trying to lose mass before the universe's end. This evaporation challenges our understanding of information loss. What happens to the stuff black holes eat? Scientists still bicker over the information paradox. As you pull back from the event horizon, you feel the universe's weight. Black holes aren't just voids. They're cosmic pranksters, bending light, stretching time, and humming eerie tunes. You're ready to leave their grip and explore stranger shores, like planets that make Earth look boring. You've slipped the grip of black holes, their eerie pull fading as you drift toward a new cosmic frontier. Alien worlds that make Earth look like a sleepy suburb. These exoplanets, orbiting distant stars, are so bizarre they sound like they were cooked up in a sci-fi fever dream. Picture yourself gliding above landscapes where rain is glass, oceans are molten metal, and the skies burn with colors you can't name. You're about to wander through the strangest planets we've found, each one a reminder that the universe loves to show off. First, you land on HD 189733b, a deep blue gas giant 63 light-years away. It looks serene like a cosmic sapphire, but don't be fooled, this place is a nightmare. A mainstream fact: discovered in 2005, it's one of the first exoplanets we studied closely, thanks to its tight orbit around its star, whipping around every 2.2 days. Its azure hue comes from silicate particles in its atmosphere, scattering light. Now the quirky twist: it rains molten glass sideways, driven by 5,400 miles per hour winds. Imagine standing there, spoiler, you'd be toast, dodging razor-sharp droplets slicing through a howling storm. Astronomers still argue whether its atmosphere holds clues to life-friendly worlds or just mocks our hopes with its hostility. You jet off to WASP-12b, a planet so close to its star it's literally melting. This hot Jupiter, found in 2008, orbits so tightly it completes a year in just over a day. Its surface hits 4,000 degrees Fahrenheit, hot enough to vaporize rock. Here's the weird bit: its star is stretching it into an egg shape, siphoning off its atmosphere like a cosmic vampire. You can almost see the planet's guts trailing into space, forming a glowing disk around its star. Joke time: why's WASP-12b so clingy? It's got no personal space from its star. Scientists debate whether it'll be completely devoured in a few million years or limp on as a charred husk. Next, you're hovering over 55 Cancri e, a super-Earth 40 light-years away. This rocky world, twice Earth's size, is a lava lover's dream. Its surface, heated to 3,600 degrees Fahrenheit, is likely covered in molten oceans, maybe graphite or even diamond. A historical nod: its discovery in 2004 marked a leap in finding Earth-like planets, though this one's more like Earth's evil twin. The quirky kicker? Some models suggest it might have a diamond core, making it the universe's most blinged-out planet. You'd think it's a jeweler's paradise, but good luck mining it without melting. Are these diamonds real or just theoretical sparkle? The debate's still hot. You drift to Trace 2b, the darkest planet we know, reflecting less than 1% of its star's light, blacker than coal. Found in 2006, It's a gas giant 750 light-years away, absorbing light like a cosmic sponge. Its atmosphere might be filled with light-eating chemicals like sodium or titanium oxide. Quirky fact: it glows faintly red like a dying ember, giving it a spooky vibe. Another joke: why's Trace 2b so moody? It's literally the goth of exoplanets. Astronomers argue whether its darkness hides exotic chemistry or just a weird atmospheric quirk. Finally, you visit Gliese 581g, a maybe habitable world 20 light-years away. Announced in 2010, it sits in its star's Goldilocks zone, where liquid water might exist. But here's the catch: it's tidally locked, one side roasting, the other freezing, with a twilight zone that might just support life. The quirky bit? We're not even sure it exists. Some data suggests it's a ghost, a statistical blip. Scientists still bicker over whether Gliese 581g is real or just our hopes projected onto the stars. Last joke: why's Gliese 581g so shy? It keeps dodging our telescopes. As you float away, these worlds linger in your mind: glass storms, diamond seas, and planets that might not even be there. The universe is a gallery of the absurd, and you're just scratching the surface. Ready for the next cosmic curveball? You're gliding through the cosmic deep end now, leaving those bizarre exoplanets behind as you plunge into a new kind of weirdness: cosmic radiation. It's the universe's invisible wildfire, zipping through space, slamming into everything, including you if you were out there without a spacesuit. Picture yourself surrounded by a ghostly buzz of particles, some born in the hearts of dying stars, others from the Big Bang itself. You're about to chase the strangest quirks of cosmic rays, those high-energy travelers that dance through the void and mess with Earth in ways you'd never expect. Cosmic rays are mostly protons, electrons, and atomic nuclei, moving at nearly light speed. A mainstream fact: they were discovered in 1912 by Victor Hess, who rode a balloon into the stratosphere and found radiation levels spiked higher up, proving they come from space. But here's the quirky bit: some cosmic rays are so energetic they pack the punch of a tennis ball served by a pro, all crammed into a single particle. These ultra-high-energy rays, detected by observatories like the Pierre Auger in Argentina, defy explanation. Nothing we know, not even supernovae, seems powerful enough to make them. Scientists still argue whether they're born in distant quasars or some unknown cosmic accelerator. You feel a tingle, imagining these rays zipping through you. They're everywhere, even on Earth, passing through your body at a rate of about 1 per square centimeter per second. Most are harmless, but they can fry electronics or mutate DNA. In the 1960s, astronauts on early space missions reported flashes in their eyes, cosmic rays hitting their retinas, creating light shows in their brains. Quirky twist: some call this the astronaut's disco, a private rave courtesy of the universe. Joke time: why do cosmic rays make bad party guests? They crash through everything and never stop moving. Now you're tracing their origins and it gets weirder. Some cosmic rays come from the sun, especially during solar flares, like the massive 1859 Carrington event that lit up Earth's skies with auroras and zapped telegraph systems. That's your historical anchor. People back then had no clue cosmic rays were involved, but today we know solar storms can shower us with these particles. The odd bit? A few rays might come from outside our galaxy, traveling billions of years to reach us, carrying secrets from the universe's wild youth. Are they messengers from ancient galaxies or just random intergalactic bullets? The debate rages on. You pause, picturing the oh my god particle, a cosmic ray detected in 1991 with energy so insane it was like a proton moving at 99.9999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 pin down what launched it. Maybe a black hole's jet like the ones you saw earlier, or a neutron star collision. It's like the universe chucked a fastball and forgot to tell us the pitcher's name. Another light jab. Why is this particle so cocky? It knows it's the fastest thing in town. Then there's the creepy side. Cosmic rays might shape life itself. They bombard Earth's atmosphere, creating secondary particles that seed clouds or spark lightning. Some fringe theories suggest they influenced early DNA, nudging evolution along. Imagine that your existence might owe a nod to a cosmic ray that zapped a primordial soup. Scientists debate whether this is legit or just a stretch, but it's wild to think the universe's radiation could be life's silent DJ. As you float, you realize cosmic rays are the universe's wild cards, invisible but relentless. They connect you to exploding stars, distant galaxies, and maybe even life's origins. It's like the cosmos is whispering secrets through these particles, and you're just starting to listen. Ready to dive into something even stranger, like the invisible stuff holding galaxies together? You're drifting through the cosmic haze, the buzz of cosmic rays fading as you stumble into the universe's most elusive mystery, dark matter. It's not shiny, it's not loud, but it's everywhere, holding galaxies together like invisible glue. Picture yourself surrounded by an unseen force, shaping the cosmos without ever showing its face. You're about to grapple with dark matter's eerie grip, a phantom that bends gravity, toys with stars, and leaves scientists scratching their heads. Dark matter doesn't emit or absorb light, yet it makes up about 27% of the universe's mass energy. A mainstream fact: in the 1930s, Fritz Zwicky noticed galaxy clusters moved too fast to be held together by visible matter alone, hinting at something unseen. He called it missing mass, and decades later, Vera Rubin's work on galaxy rotation curves in the 1970s sealed the deal. Stars at galaxy edges spun too quickly without an invisible anchor. But here's the quirky bit. Some theorize dark matter could form ghost stars, invisible clumps mimicking real ones, lurking in galaxies like cosmic squatters. Historians still argue whether these hypothetical structures exist or if dark matter's just too slippery to form anything so fancy. You feel its presence like a shadow you can't shake. Dark matter's gravity bends light from distant stars, creating warped images called gravitational lenses. Think of it as the universe's funhouse mirror. You saw this with black holes, but dark matter does it on a galactic scale. In 2006, the Bullet Cluster's collision showed dark matter separating from normal matter, a cosmic divorce caught on telescope. The quirky twist? Some galaxies like NGC 1052 DF2 seem to have almost no dark matter, defying everything we thought we knew. Why are they so empty? Scientists debate if these oddballs challenge dark matter's role or just prove it's weirder than we thought. Now, imagine dark matter particles zipping through you right now, billions per second, passing like ghosts through your body. Experiments like the Large Underground Xenon Detector hunt for these particles, buried deep to avoid cosmic ray noise. No luck yet, but the idea of dark matter ignoring normal matter is spooky. Joke time: why is dark matter so aloof? It's got no time for our visible drama. The quirky kicker: some fringe theories suggest dark matter might interact with itself, forming invisible ecosystems we'll never see. You drift toward a historical anchor, the cosmic microwave background (CMB), the universe's baby photo, mapped by satellites like Planck in 2013. Its tiny temperature ripples show dark matter's fingerprints, shaping how galaxies formed. But the weird bit? Some CMB anomalies, like the cold spot, might hint at dark matter doing something unexpected, like clumping unevenly in the early universe. Are these glitches proof of new physics or just cosmic noise? The debate's still sizzling. Then there's the wild card: dark matter might not be particles at all. Some propose it's tiny black holes from the Big Bang, like those rogue ones you met earlier, or even wrinkles in spacetime. Imagine that the universe's backbone could be a glitch in reality itself. Another light jab: why doesn't dark matter throw a party? Because it'd be invisible and nobody'd show up. The idea challenges everything, and scientists still bicker over whether dark matter's a substance or a cosmic trick. As you float, you sense dark matter's grip everywhere. Galaxies spin because of it, light bends, and the universe holds its shape. Yet it's a ghost, teasing us with its silence. You're ready to leave this invisible puzzle behind and dive into something even stranger, like how the universe plays with time itself. You're floating in the cosmic tide, the invisible tug of dark matter fading as you slip into a new kind of weirdness: time itself. The universe doesn't just stretch space, it messes with your clock, twisting moments near black holes or in the fiery chaos of the Big Bang. Picture yourself caught in a temporal current, where seconds stretch into centuries or shrink to nothing. You're about to unravel how time warps, loops, and maybe even breaks, making you question what now even means. Time isn't the steady tick-tock you know. Near a black hole like the ones you skirted earlier, it slows to a crawl, Einstein's general relativity at work. A mainstream fact: in 1976, the Gravity Probe A experiment shot a clock into space, confirming time runs faster farther from Earth's gravity, matching Einstein's predictions to the nanosecond. But here's the quirky twist: some black holes spin so fast they drag spacetime with them, a phenomenon called frame dragging. You could, in theory, orbit one and return to find your friends long gone, aged out while you're still picking cosmic lint off your jacket. Scientists still argue whether this time travel is practical or just a mathematical prank. You drift back to the universe's birth, the Big Bang, 13.8 billion years ago. Time didn't exist before it, or did it? The Planck epoch, the first 10 to the power of -43 seconds, is so dense and hot that physics breaks down. Quirky bit. Some cosmologists suggest time might have been fuzzy, not linear, like a scrambled signal. Imagine trying to set a meeting in that mess. A historical nod. Georges Lemaitre proposed the Big Bang idea in 1927, calling it the primeval atom, long before it became textbook truth. The debate rages on. Did time start with a bang, or was there a before? Now, picture wormholes, those theoretical tunnels you'll explore later. They might not just link places but times, letting you pop out in the Jurassic era, if you survive the trip. The catch. They'd need exotic matter to stay open, stuff we've never found. Joke time. Why is time travel so unreliable? The universe keeps losing your luggage in the fourth dimension. Some fringe theories suggest tiny, fleeting wormholes could let time leak between moments, making reality glitchier than a bad Wi-Fi connection. You're now hovering near a neutron star where time also plays tricks. These dense corpses of stars, like the magnetars you met, have gravity so intense that a clock on their surface would tick slower than one on Earth. In 1983, the discovery of the millisecond pulsar PSR B 1937+21 showed these stars spin so fast they rival atomic clocks for precision. Quirky twist. Some pulsars might glitch because their interiors shift, briefly messing with their timing like a cosmic hiccup. Are these glitches random or signs of deeper physics? Scientists still bicker. Then there's the cosmic speed limit, light speed. If you could ride a photon, time would freeze for you while the universe ages around you. This comes from special relativity, tested in 1977 when particle accelerators showed muons, short-lived particles, last longer when moving near light speed. The weird bit? Some speculate the universe's expansion might stretch time itself, making future seconds longer than today's. Another light jab. Why is the universe bad at keeping time? It's always expanding its schedule. As you float, you realize time's not a straight line. It's a cosmic rubber band stretched by gravity, warped by speed, and maybe looped through unseen tunnels. You're a speck in this temporal dance, and the universe is keeping the beat. Ready to leave time's quirks behind and explore the galaxies that look like they belong in a surrealist painting? You're gliding through the cosmic haze, time's weird twists still tugging at your thoughts as you shift focus to the universe's grandest artworks, galaxies. These aren't just tidy spirals like the Milky Way. Some look like they were painted by a cosmic artist having a meltdown, jellyfish, rings, or total train wrecks. Picture yourself soaring above these stellar cities, their bizarre shapes glowing against the void. You're about to marvel at galaxies that defy logic, each one a testament to the universe's wild imagination. Start with jellyfish galaxies, sprawling systems with glowing tendrils trailing like cosmic sea creatures. A mainstream fact. These galaxies, like JO206 and the Able 901/902 cluster, were spotted in the 2000s by the Hubble Space Telescope. Their tails formed when they plow through hot intergalactic gas, stripping away stars and gas. It's called ram pressure stripping, a galactic makeover by force. But here's the quirky bit. Some jellyfish galaxies birth new stars in their tails, like cosmic afterthoughts, glowing brighter than the galaxy itself. Scientists still argue whether these tails are fleeting or could spawn mini-galaxies of their own. You drift toward ring galaxies, rare oddballs that look like cosmic donuts. The Cartwheel Galaxy, 500 million light-years away, is a classic, formed when a smaller galaxy punched through a larger one's center, sending ripples of star formation outward. Historical nod. It was first catalogued in 1941, but only later telescopes revealed its ring structure. Quirky twist. Some ring galaxies might hide spokes, faint stellar bridges connecting their centers to the outer ring, like a cosmic bicycle wheel. Are these spokes real or just telescope artifacts? The debate's still spinning. Joke time. Why is the Cartwheel Galaxy so flashy? It's showing off its new rim job. Now you're hovering over interacting galaxies, pairs or groups caught in gravitational dances that warp them into bizarre shapes. The Mice galaxies, NGC 4676, look like cosmic tadpoles with long tails of stars and gas, stretched by their mutual pull. Discovered in the 18th century, they're a textbook case of galactic collisions, observed in detail by Hubble in 2002. The weird bit? These collisions can trigger starburst phases, birthing stars at a frantic pace, like the universe hit fast forward. Scientists bicker over whether these mergers always end in a single, bloated galaxy or sometimes fizzle out. Then there's the cosmic train wreck. Irregular galaxies like the Large Magellanic Cloud you glimpsed earlier, which the Milky Way is slowly gobbling. Irregulars have no clear shape, no spiral arms, no tidy disk, just chaotic clumps of stars and gas. The quirky kicker? Some, like Izwiki 18, look young, with stars forming like it's the early universe despite being billions of years old. It's like finding a teenager with a pension plan. Another light jab. Why is Izwiki 18 so youthful? It's got the universe's best anti-aging cream. Finally, you spot polar ring galaxies, where a ring of stars and gas orbits perpendicular to the main disk, like a cosmic hula hoop. NGC 4650A, studied since the 1980s, is a prime example, likely formed when a galaxy swallowed a smaller one at a weird angle. The quirky part? These rings can outshine the galaxy's core, stealing the spotlight. Are polar rings stable or doomed to fade? Astronomers still debate. Last joke. Why is NGC 4650A so extra? It's rocking two outfits at once. As you float away, these galaxies linger in your mind, jellyfish trailing stardust, rings spinning in defiance, and chaotic wrecks blazing with new stars. The universe is a gallery of the absurd, and you're ready to listen to its next secret, the eerie sounds humming through the void. You're soaring through the cosmic gallery, those wild galaxies fading into the distance as you tune into something new, the universe's eerie soundtrack. It's not silent out there. Space hums, crackles, and even screams with sounds you can't hear with your ears but can feel in your bones. Picture yourself as a cosmic DJ, picking up signals from quasars, pulsars, and mysterious bursts that echo across the void. You're about to listen to the strangest noises the universe makes, each one a whisper from the stars. Start with the hum of a black hole, like the one you encountered in the Perseus cluster. Its pressure waves ripple through hot gas, creating a note so low it's a billion times deeper than anything you'd hear at a concert. A mainstream fact: NASA's Chandra X-ray Observatory caught this sound in 2003, translating it into human range for us to marvel at. It's like the universe's bass line, steady and haunting. But here's the quirky bit. Some black holes might sing in harmony, their vibrations syncing with nearby gas clouds to amplify the sound. Scientists still argue whether these cosmic concerts regulate galaxy growth or are just background noise. You tune your cosmic radio to pulsars, those spinning neutron stars you glimpsed earlier. They beam radio waves like lighthouses, creating rhythmic pulses we can detect. In 1967, Jocelyn Bell Burnell discovered the first pulsar, PSRB 1919+21, its signal so regular it was briefly mistaken for an alien broadcast. Historical anchor, her find revolutionized astronomy, proving neutron stars exist. The quirky twist? Some pulsars emit fast radio bursts, FRBs, millisecond-long blips of energy that scream across billions of light-years. One FRB 121102 repeats like a cosmic SOS. Are these bursts from magnetars or something stranger like alien tech? The debate's still crackling. Joke time. Why is the pulsar so punctual? It's got the universe's tightest schedule. Now you catch a ghostly whistle from the early universe, the cosmic microwave background's faint hum, a snapshot of the Big Bang's afterglow. Satellites like WMAP in 2001 mapped its temperature ripples, but when converted to sound, it's a low, eerie drone, like the universe exhaling. Quirky fact: some patches like the CMB's cold spot sound off-key, hinting at weird physics or maybe a brush with another universe. Scientists bicker over whether this spot is a statistical fluke or a cosmic Easter egg. Then there's the WOW signal, a 72-second radio blast caught in 1977 by the Big Ear telescope. It was so strong and narrow it screamed, "Not natural," yet we've never heard it again. The quirky kicker? Some say it could have been a comet's emission, but others cling to the alien hypothesis, imagining ET phoning home. Another light jab. Why'd the WOW signal ghost us? It got stage fright after one performance. Astronomers still debate whether it was a one-off cosmic hiccup or a missed call from the stars. Finally, you hear the eerie screams of merging black holes. When two collided in 2015, LIGO detected their gravitational waves, which, when turned into sound, resemble a chirp rising to a whoop. It's the sound of space-time itself wobbling. The weird bit? These mergers might produce faint radio echoes, like cosmic aftershocks, picked up by telescopes years later. Last joke. Why do black holes make bad singers? Their duets always end in a crash. As you drift, these sounds linger, a deep hum, a pulsing beat, a fleeting scream. The universe isn't just a sight, it's a symphony, and you're tuned in, ready to face something even stranger, like the dangerous twin of everything you know? You're still humming with the universe's eerie soundtrack, those cosmic beats fading as you drift toward a new kind of danger. Antimatter, the mirror twin of everything you're made of. Picture yourself hovering near a particle that could annihilate you in a flash. turning matter into pure energy. It's the universe's most explosive sibling rivalry, and you're about to confront antimatter's wild nature, its scarcity, and why it's the ultimate cosmic tease. Antimatter sounds like sci-fi, but it's real. Particles identical to normal matter but with opposite charges like positrons to electrons. When they meet, they vanish in a burst of energy, releasing more power per gram than a nuclear bomb. A mainstream fact: Paul Dirac predicted antimatter in 1928, and Carl Anderson confirmed it in 1932 by spotting positrons in cosmic rays, like the ones you chased earlier. But here's the quirky bit: antimatter is so rare it's practically the universe's unicorn. Theory says the Big Bang should have made equal amounts of matter and antimatter, yet we're stuck in a matter-dominated cosmos. Scientists still argue whether this baryon asymmetry comes from some cosmic bias or a hidden process that tipped the scales. You imagine holding a gram of antimatter, if you could survive the blast. At CERN, scientists trap tiny amounts in magnetic fields, studying them like caged lightning. In 2011, they held anti-hydrogen atoms for 16 minutes, a record, but making more is absurdly hard. Quirky twist: some estimate producing a single gram would cost $62.5 trillion and take millions of years with current tech. Joke time: why is antimatter so expensive? It's got the worst exchange rate in the universe. Now you're gliding through space where antimatter hides in plain sight. Cosmic rays carry positrons, likely born in pulsar winds or black hole jets like those you've seen. The Alpha Magnetic Spectrometer on the International Space Station has been hunting them since 2011, finding hints of excess positrons that might, big maybe, point to dark matter collisions, tying back to that invisible glue you explored. The weird bit? Some positrons might come from nearby pulsars, not exotic physics, making scientists debate whether we're chasing ghosts or breakthroughs. You drift to a historical anchor. In 1995, CERN created the first anti-atoms, 9 anti-hydrogen atoms that lasted mere nanoseconds. It was a triumph, proving antimatter isn't just theory. But the quirky kicker? Some wonder if antimatter behaves differently under gravity. Does it fall up instead of down? Experiments like AlphaG at CERN are testing this, and if true, it'd flip physics on its head. Another light jab: why is antimatter so contrary? It's literally born to disagree with gravity. Then there's the wild idea: antimatter stars. If entire galaxies of antimatter exist, they'd look identical to normal ones from afar, hiding in plain sight. No evidence yet, but the Fermi Gamma Ray Telescope scans for gamma-ray bursts from matter-antimatter collisions at galaxy edges. None found, but the possibility's tantalizing. Last joke: why don't antimatter stars shine brighter? They're too busy canceling their own spotlight. Scientists bicker over whether such galaxies could exist or if the universe's matter bias rules them out. As you float, antimatter's danger lingers like a cosmic dare. It's scarce, explosive, and maybe even defies gravity's pull. You're a speck in a universe that plays favorites with matter, and antimatter's the rebel sibling, always threatening to spark a fight. Ready to dive into the scars of cosmic battles, where galaxies clash and leave dazzling wreckage. You're drifting away from antimatter's explosive drama, its volatile sparks fading as you sail toward the universe's battlegrounds, where galaxies collide and leave behind epic scars. Picture yourself weaving through cosmic wreckage, stars torn apart, gas clouds twisted, and dazzling new creations born from chaos. These aren't quiet mergers, they're galactic pileups reshaping the cosmos with violent beauty. You're about to trace the aftermath of these collisions, each one a testament to the universe's reckless creativity. Galactic collisions are slow-motion spectacles, taking millions of years, but their impact is wild. A mainstream fact: the Antennae galaxies NGC 4038/4039, observed in detail by Hubble in 1997, show two spirals smashing together, their arms twisted into tidal tails stretching 100,000 light-years. These crashes spark starbursts, birthing millions of new stars in fiery nurseries. But here's the quirky bit: some collisions create tidal dwarf galaxies, mini-galaxies formed from debris like cosmic recycling. Scientists still argue whether these dwarfs are stable or just temporary glitter in the wreckage. You glide closer, feeling the gravitational tug of the chaos. The Milky Way, that cannibal you met earlier, bears scars from past collisions. The Gaia Sausage, a stream of stars discovered in 2018 by the Gaia satellite, is debris from a galaxy the Milky Way devoured 10 billion years ago. Historical anchor: this find rewrote our galaxy's history, showing it's a serial eater. The quirky twist? Some of these stars are older than the Milky Way's own, like cosmic heirlooms stolen from a rival. Are these streams permanent or will they dissolve into the galaxy's disk? The debate's still swirling. Now you're hovering over Stephan's quintet, a group of 5 galaxies caught in a gravitational brawl 290 million light-years away. First catalogued in 1877, it's a cosmic soap opera, with 4 galaxies tangling while the 5th just watches. Their collisions create shockwaves, heating gas to millions of degrees and sparking X-ray glows, caught by Chandra in 2000. The weird bit? One galaxy, NGC 7320, might not even be part of the group, just a foreground imposter photobombed into the scene. Joke time. Why is NGC 7320 so sneaky? It's crashing the cosmic party without an invite. Scientists bicker over whether it's truly distant or secretly in the mix. You drift to another scar, galactic bridges like the one connecting the Magellanic Clouds, those satellites the Milky Way's snacking on. These bridges are streams of gas and stars pulled by gravity during close encounters, glowing faintly like cosmic titropes. The quirky kicker? Some bridges host star clusters born mid-collision, like babies born in a car crash. Another light jab: why do galaxies form bridges? They're just trying to stay connected in this long-distance relationship. Finally, you spot the cosmic ripples of collisions like those in the Virgo cluster, where galaxies jostle and distort each other. These interactions can strip galaxies bare, leaving jellyfish tails like the ones you saw earlier, or create shells of stars around survivors. The weird bit? Some shells, seen in galaxies like NGC 3923, might hint at ancient mergers we're only now decoding. Last joke: why is the Virgo cluster so messy? It's the universe's worst roommate, leaving scars everywhere. Are these shells clues to a single crash or multiple hits? Astronomers still debate. As you float away, the wreckage of these collisions lingers, tails, bridges, and starbursts painting a universe that thrives on chaos. You're ready to ponder the next mystery, the pieces of the cosmos that just don't add up. You're drifting through the cosmic debris of galactic collisions, their glowing scars fading as you turn toward a new puzzle, the universe's missing pieces. It's like the cosmos is a jigsaw with holes, stuff that should be there but isn't, or things we can't explain. Picture yourself sifting through the void, chasing ghostly gaps like lost lithium or rogue moons that defy our best theories. You're about to ponder the strangest absences in cosmology, each one a clue that the universe isn't playing fair. Start with the lithium problem, a cosmic head-scratcher. The Big Bang should have cooked up specific amounts of light elements, hydrogen, helium, and lithium, based on our models. A mainstream fact: measurements of the cosmic microwave background, like those from the Planck satellite in 2013, match predictions for hydrogen and helium perfectly, but lithium's off. We see only a third of the lithium expected in old stars. Quirky bit: some stars seem to eat their lithium, burning it in their cores, but that doesn't fully explain the gap. Scientists still argue whether the missing lithium points to flaws in Big Bang nucleosynthesis or some exotic physics we haven't cracked. You shift to rogue moons, those wanderers that don't orbit planets like good little satellites. In 2018, astronomers spotted a possible exomoon around Kepler 1625b, a gas giant 8,000 light-years away, but its size, Neptune-like, makes it more like a planet in disguise. Historical anchor: moons were first studied systematically when Galileo spotted Jupiter's in 1610, setting the stage for modern astronomy. The quirky twist? Some theorize rogue moons, kicked out during planetary collisions, might drift alone, maybe even hosting life in subsurface oceans like those rogue planets you met earlier. Are these moons common or cosmic flukes? The debate's still orbiting. Now you're grappling with the missing satellites problem. Our galaxy should be swarmed with dwarf galaxies, based on dark matter models you explored. Simulations predict hundreds, but we've only found about 50 around the Milky Way. The quirky kicker? Some missing satellites might be dark galaxies, rich in dark matter but nearly starless, invisible to our telescopes. Joke time: why are these galaxies so shy? They're allergic to the spotlight. Scientists bicker over whether our models are wrong or if these dark galaxies are just hiding. Then there's the Hubble tension, a cosmic mismatch. The universe's expansion rate, measured by the Hubble Space Telescope in the 1990s and refined later, doesn't match what we calculate from the early universe's CMB data. It's like the cosmos is speeding up faster than it should. The weird bit? Some propose new particles like early dark energy to fix the gap, while others think we're misreading the data. Another light jab: why is the universe in such a rush? It's late for a cosmic meeting. Finally, you ponder missing baryons, normal matter that should be floating in the intergalactic medium. X-ray telescopes like XMM Newton in 2017 found some in hot gas filaments, but half are still AWOL. Quirky twist: they might be hiding in a warm hot intergalactic medium, a cosmic fog too faint to detect. Last joke: why is the universe bad at hide and seek? Keeps losing half its stuff. Are these baryons in plain sight or locked in some unseen form? The debate rages on. As you float, these gaps, lithium, moons, galaxies, and matter, feel like the universe's taunts, daring you to solve its riddles. You're ready to chase the next mystery, something wilder, like tunnels that could shortcut the cosmos itself. You're still reeling from the universe's missing pieces, those cosmic gaps teasing your curiosity as you glide toward a new enigma: wormholes. These aren't just sci-fi shortcuts, they're theoretical tunnels that could link distant corners of space, or even time, like a cosmic subway system. Picture yourself hovering at the mouth of one, space-time folding around you, stars blurring as you contemplate diving in. You're about to explore the strangest possibilities of wormholes, where the universe might let you cheat distance and rewrite the rules. Wormholes come from Einstein's general relativity, the same math that warped time near black holes you visited earlier. A mainstream fact: in 1935, Einstein and Nathan Rosen proposed Einstein-Rosen bridges, theoretical tunnels connecting two points in spacetime. They're not physical objects but distortions, like folding a sheet of paper to touch two distant dots. The quirky bit? Keeping a wormhole open requires exotic matter with negative energy, something we've only seen in tiny quantum effects, like the Casimir effect measured in 1948. Scientists still argue whether this exotic matter exists in enough quantity or if wormholes are just mathematical daydreams. You imagine stepping through a wormhole, popping out light years away, or maybe in another era like that time-warping idea you pondered. The catch is stability. Most theoretical wormholes collapse faster than you can say, interstellar shortcut. Quirky twist: some propose using dark energy, that mysterious force speeding up the universe's expansion, to prop them open. It's like using cosmic WD-40 to grease the tunnel. Joke time: why is a wormhole a bad commute? It keeps closing before you reach the other side. The debate rages: could we engineer a traversable wormhole, or are they forever theoretical? You drift to a historical anchor. In 1988, physicist Kip Thorne and his team fleshed out traversable wormholes for the book Contact by Carl Sagan, making them plausible in theory. Their work showed a wormhole could stay open with exotic matter, but you'd need a lot. Think planet-sized amounts. The weird bit? Some wormholes might connect to other universes, not just distant stars. Imagine popping out in a reality where gravity's weaker or stars burn green. Scientists bicker over whether these multiverse wormholes are possible or just wild speculation. Now, picture microscopic wormholes, tiny tunnels flickering in and out of existence at the quantum level. The Planck scale foam, a concept from quantum gravity, suggests spacetime is bubbly, with wormholes smaller than atoms popping like cosmic champagne. The quirky kicker? These mini wormholes might let information leak between points in space, explaining weird quantum effects like entanglement. Another light jab: why are these wormholes so tiny? They're the universe's smallest escape hatches. Are they real or just quantum noise? The debate's still bubbling. Then there's the wild idea: wormholes as time machines. If one end moves near light speed or sits in strong gravity, time could shift, letting you exit before you entered. This loops back to the time-twisting black holes you explored. The catch: paradoxes like meeting your past self make physicists nervous. Last joke: why don't wormholes do time travel? They're afraid of causing a cosmic family reunion. Scientists still argue whether these time loops are forbidden by physics or just really tricky. As you hover at the wormhole's edge, the universe feels like a maze with hidden doors. These tunnels tease the possibility of shortcuts, new realities, or even time travel, but they're maddeningly out of reach. You're ready to face the final frontier, the universe's possible endings, where everything you've seen might fade or collapse. You're slipping away from the tantalizing lure of wormholes, their cosmic shortcuts fading as you drift toward the universe's ultimate question: how does it all end? Picture yourself floating at the edge of everything, stars dimming, galaxies dissolving, the void stretching into eternity. You're about to face the strangest fates the cosmos might have in store: collapse, freeze, or something even wilder. Each possibility is a reminder that even the universe isn't forever. One ending is the Big Crunch, where the universe's expansion, driven by dark energy you touched on earlier, reverses. Gravity wins, pulling galaxies back into a fiery, dense point like the Big Bang in reverse. A mainstream fact: In the 1920s, Alexander Friedman's equations showed the universe's fate depends on its density, with early observations suggesting a crunch was possible. But here's the quirky bit. Some models suggest a big bounce, where the crunch sparks a new Big Bang, rebooting the cosmos like a cosmic video game. Scientists still argue whether dark energy strength rules out a crunch or if new physics could flip the script. You glide toward the opposite fate, the big freeze or heat death. Here the universe keeps expanding, stars burn out, and everything spreads too thin to form new ones. In a trillion years, it's just a cold, dark soup of particles. Historical anchor. This idea stems from the 1850s when Rudolf Clausius introduced entropy, showing systems trend toward disorder. The quirky twist? Some pockets might form Boltzmann brains, random, self-aware entities popping up in the chaos thinking they're you. Joke time. Why's the big freeze so lonely? Even the universe ghosts itself in the end. Are these brains real or just statistical nonsense? The debate's chilling. Then there's the big rip, where dark energy goes rogue, accelerating expansion so fast it tears galaxies, stars, even atoms apart. In 2003, Robert Caldwell proposed this model, suggesting it could happen in 20 billion years if dark energy strength spikes. The weird bit? Time might end as space-time itself rips, leaving nothing but a void. Another light jab. Why's the big rip so dramatic? It's the universe's ultimate temper tantrum. Scientists bicker over whether dark energy could ever get that wild or if it's just a theoretical overreach. You drift to a wilder idea: vacuum decay. If the universe's vacuum state isn't stable, a bubble of true vacuum could form, expanding at light speed, rewriting physics as it goes. Everything, stars, planets, you, would dissolve instantly. The quirky kicker? This could have started billions of years ago and we'd never know until the bubble hits. Historical nod. This idea emerged in the 1980s from quantum field theory, building on Higgs boson research. Are we safe or is a bubble already racing toward us? The debate's unsettling. Last joke. Why's vacuum decay so sneaky? It's the universe's ultimate surprise party. Finally, there's the cyclic model, where the universe oscillates between big bangs and crunches, an eternal loop. Some versions tie to string theory, suggesting extra dimensions drive the cycle. The quirky bit? Each cycle might leave faint echoes in the cosmic microwave background. Like cosmic déjà vu, scientists still argue whether these echoes exist or if the cycle's just a hopeful story. As you float, the universe's endings loom: crunch, freeze, rip, or rebirth. Each feels like a cosmic coin toss and you're just a speck in the gamble. Ready to reflect on your place in this infinite mess? You're hovering at the edge of the universe's possible fates, those apocalyptic endings lingering like a faint chill as you turn inward, reflecting on your place in this vast, wild cosmos. Picture yourself as a tiny spark, adrift in a sea of stars, galaxies, and mysteries you've wandered through, rogue planets, singing black holes, and time-twisting wormholes. It's humbling but also wondrous to be a speck in this infinite tapestry. You're about to explore what it means to be human in a universe so strange, so grand, and so utterly indifferent. You start with a simple truth: you're made of stardust. Every atom in your body, carbon, oxygen, iron, was forged in the hearts of ancient stars, like those pulsing Cepheids or exploding supernovae you met earlier. A mainstream fact. In the 1960s, astronomers like Fred Hoyle confirmed that stellar nucleosynthesis creates the elements we're built from, linking you to the cosmos. But here's the quirky bit. Some of your atoms might have come from a single star, scattered across light years, meaning you're a cosmic collage, pieced together from stellar explosions. Scientists still argue whether most heavy elements come from supernovae or neutron star collisions, like the ones that chirp gravitational waves. You gaze out, feeling small yet connected. The universe is 93 billion light-years wide, and you're a fleeting blip on one pale blue dot, as Carl Sagan called Earth in 1990. That's your historical anchor. His words reminded us how tiny yet precious our world is. The quirky twist? Your thoughts, your dreams, are among the universe's rarest things. Consciousness might be scarcer than antimatter, a fluke in a cosmos of gas and rock. Are we alone, or is the universe teeming with minds we'll never meet? The debate burns on, fueled by every exoplanet you explored. You drift, imagining your role in the cosmic story. Every signal we send, radio waves, Voyager's golden record, might outlast humanity, carrying your voice to stars you'll never see. The quirky bit? Some signals, like the 1974 Arecibo message, were aimed at star clusters, hoping for an alien reply we might not get for 50,000 years. Joke time. Why's the universe a bad pen pal? Takes forever to write back. You're tied to those cosmic sounds you heard, wondering if someone somewhere is listening. Then there's the Fermi paradox, the eerie silence where alien civilizations should be. Historical nod. Enrico Fermi posed it in 1950, asking why we see no signs of ET despite billions of habitable worlds, like Gliese 581g. The weird twist? Maybe aliens are hiding in dark planets, powered by dark matter, invisible to our telescopes. Another light jab. Why don't aliens visit? They saw our reality TV and canceled the trip. Scientists bicker over whether we're alone, filtered out by cosmic barriers, or just not looking hard enough. You pause, feeling the weight of infinity. Yet your smallness is your strength. Every question you ask, every telescope we point, pushes back the void. The quirky kicker. Your curiosity mirrors the universe's chaos. Both are restless, always seeking. Last joke. Why were you perfect for the cosmos? You're both tiny and full of wonder. Are we insignificant or the universe's way of knowing itself? The debate's as old as stargazing. Wind down. As you float, the universe softens around you. The stars dim gently, their light a whisper against the velvet dark. You're wrapped in the cosmos's quiet embrace, its mysteries settling like dust in a still room. Those rogue planets, screaming black holes, and vanishing galaxies feel distant now, their wildness fading into a calm hum. You're not just a speck, you're part of the story, a fleeting thought in the universe's vast mind. Let the galaxy spin on without you for now. Close your eyes, let the fan's software carry you, and sink into the peace of the infinite. The cosmos will still be there when you wake, ready to surprise you again. Sleep well, dreamer, under the stars' gentle watch.